The function f is defined for all x. Use the graph of the first derivative to decide a over what interval as f is increasing or decreasing, and b does f has a local maximum or minimum, if so, which and where. And we are giving the first derivative. Notice this is the graph of the first derivative, not the graph of the function of x. So remember, of the first derivative is positive, then f is increasing, and of the derivative is negative, then f is decreasing. So for a, what we have to care about, the x-axis, as the graph is above the x-axis or below the x-axis. So here, if it's above the x-axis, then f of x is positive, which means the first case, which f is increasing, our original function is increasing. And then for lower than x value, what we see that f of x is negative, therefore the function is decreasing. Now for b, a local maximum or minimum is a critical point, and that gonna happen whereas the first derivative, which we are given, equal to 0. And also we have to care about the signs of the f of prime, which is also shown in the graph. So here what we notice, where is our critical point? It's here when we have intersection with the x-axis. It is at x equal to 0. And notice now here the behavior of this function. The function, it's decreasing and then it's increasing. This is the f function. This is the original function. So the function f of x is decreasing and then the function f of x is increasing. This is from part A. So when we draw a shape, we can see x is 0 is a local minimum. Now for this function, again, this is f of prime of x. So remember, when the derivative is positive, f is increasing, and when the derivative is negative, f is decreasing. So if it's above the x-axis, then f of prime of x is positive, which means the function is increasing over that interval. And then we don't have anything at the bottom, so f of x is just increasing all over the interval. So for part B, again, we'll have a critical point where the first derivative is 0. This function is just increasing, which means that we don't have any intersection with the x-axis. Therefore, we don't have a critical point in here to have a local maximum or minimum. For this function f of prime of x, so notice here in the top, f of prime is positive, and here at the bottom, f of prime of x is negative. So we can use the rule. So again, on the top, f of prime of x is positive, which means the function f of x is increasing over that interval. And then at the bottom, f of prime of x is negative, therefore the function f of x is decreasing over that interval. So for part B, again, we will have a local maximum and minimum at a critical point. So a critical point is where the first derivative is 0, and we are given actually the first derivative. So that's gonna be when we have an intersection with the x-axis. That's gonna be when x is 0 and when x is 4. Now we have to determine if this is a local maximum or minimum. So we have to see the behavior of the derivative or the function. So we notice here at x equal to 0 on the left, the function is decreasing, and on the right, the function f of x is increasing. This is the function, not f of prime of x. So from the shape, x equal to 0 is a local min. And here at x equal to 4, what we notice, the derivative on the left is positive, which means the function is increasing, and then on the left is the opposite. of x is decreasing. So when we grow the shape of the function of x, it's going to increase in value and then it decrease in value. You can see now in the graph that x equal to 4 is a local max. So for number 4, the f prime of x looks like this. So we notice on this interval, f prime of x is positive. So again, if it's above the x-axis, then f prime of x is positive, which means the function over that interval is increasing. And then in this interval, f prime of x is negative, which means the function f of x is decreasing over that interval. So this is part A. For part B, we have to find a critical point first to determine if it's a local maximum or minimum. So remember, critical point is where the first derivative is 0, and this is the graph of the first derivative. So when we have an intersection with the x-axis, again, gonna be -1, 0, and gonna be 1. So 3 critical points. Now we have to determine if there are local max or min. We can do that using the signs of the first derivative over a function f of x. So x equal to -1, on the left side, the derivative is negative, which means the function is decreasing over that interval. And then on the right side is the opposite. Therefore, the function there is increasing. So when we graph it, f of x is gonna be look like a decreasing value and then increasing value. That shape is a local min. So x equal to 1 is a local min. Now at x equal to 0, so notice that on the right, let's start with the right. On the right, we notice that the derivative is 0 there, which means the function f of x is decreasing. And then on the right, it's the opposite. So f of x is increasing. So when we graph the function, it's gonna be first increasing and then decreasing. So at x equal to 0, it's a local max. Now, at x equal to 1, on the right side, we can see that the first derivative is positive, which means the function is increasing, and on the right side, on the left side, is the opposite. The derivative is negative, which means the function there is decreasing. So when we graph the function of x, it's look like something like this. Therefore, x equal to 1 is a local min.